Thank you all for coming. Now presenting Tim Burns with Ideal Power.
All right, so our technology at Ideal Power is what we call the B-TRAN. It is a disruptive power semiconductor technology that has pretty significant advantages over conventional power switches like IGBTs in many markets. B-TRAN has the potential to displace conventional power semiconductor technologies in some pretty significant, large and growing markets with some macro trends behind them. Things like electric vehicles, renewable energy, energy storage, and solid-state circuit breakers, as well as motor drives. We introduced our first commercial product here earlier this year in January, and we expect our first commercial sales of that product here later this year. Our business model is asset-light, established business model. We leverage the existing silicon infrastructure that's already out there. So we just have a core technical team, a testing lab, and a small outward-facing business development team is part of the organization. We do not own a fab, nor do we have any intention on owning a fab, so very minimal capital requirements as well. We're currently engaged in multiple target customers and key market segments, and we'll talk more about those. From a cash perspective, we're in pretty good shape. We burned through just under $7 million last year, expect to burn through roughly $8.5 million this year. We have enough cash on the balance sheet to take us through 2024. And the technology is broadly patented. So we have a patent estate of 72 issued and 24 pending patents. So what is the B-TRAN? You can see here an image of a B-TRAN die. If you flip that over, it would look the exact same on the other side of the die. That's pretty unique, is the fabrication on both sides of the wafer. And then also, just like an IGBT or MOSFET is an architecture, B-TRAN is an architecture. So we're making it in silicon today, but we could make it in other materials such as silicon carbide in the future. The compelling advantages of B-TRAN, bidirectional switching. So typically with conventional devices, you need several devices to make a bidirectional switch. So you can handle energy flow basically in both directions, particularly important in applications involving batteries when you have to charge and discharge the battery. Also significantly lower losses, particularly conduction losses, which results in energy savings during an EV increased range. And then also losses generate heat. So the fact that it has lower losses means there's less heat to dissipate, so the OEM product designs can actually be smaller and lower cost if they incorporate B-TRAN rather than conventional technologies. You can see here in a bidirectional switching application, so for the B-TRAN, it is a single device. If you use IGBTs, you basically have one IGBT and blocking diode to handle energy flow in one direction, and a second IGBT and blocking diode to handle energy flow in the other direction. So we're replacing 4 devices with one. And if you look at conduction losses in bidirectional applications, it's greater than a 4 times better than the IGBT and blocking diode to make a bidirectional circuit. So significantly improved efficiency. The IGBT market already $7 billion market, projected to grow to $11 billion by 2026. You can see here, interestingly, that the largest segments of that market are already the electric vehicle and hybrid electric vehicle segment of the market, as well as renewable energy. We'll talk more about these here in a moment. So for us, the key addressable market segments, again, electric vehicles and hybrid electric vehicles. If you see in the graphic here, just some of the places where switches are utilized in EVs. We're really focused on the power applications. But the EV market's already a $1.5 billion IGBT market, and we're looking to displace IGBTs in that market. The impacts in electric vehicles, it's really the power components of the EV where the B-TRAN really makes a significant difference. Let's look at the traction inverter, the power to DC to DC converters, the onboard charger, as well as circuit protection throughout the vehicle. The largest cost component, obviously, of an EV is the battery, but the second largest cost component is actually the semiconductor switches. So they represent 8 to 10% of the total production cost of an EV. So if you can have a significant impact on the power switch component, both in cost and performance, it has a significant impact on the overall cost and efficiency of the vehicle. So besides just reducing the number of devices needed in bidirectional circuits within the vehicle, when you look at the performance improvement over the B-TRAN compared to IGBTs, it would result in a 7 to 10% improvement in the range of the vehicle. So range anxiety is probably one of the leading factors on why people haven't adopted EVs more quickly. The B-TRAN has a direct impact on that range. Other key addressable markets, renewable energy, also over $1 billion market segment for IGBTs, data centers and cloud storage, about $500 million market. That's another one where the conduction losses are particularly important. So we did some work looking at a large commercial data center. And if you had the UPS systems in that data center, which is the uninterruptible power supply, all the electricity into that data center flows through those UPS systems. So they're continuously conducting electricity. So right now there's a significant amount of loss because of the inefficiency of IGBTs. If you replace those IGBTs in the UPS systems with B-TRAN devices, you would save over $2 million a year in annual electricity savings just because of the improved efficiency. So pretty significant. B-TRAN enables circuit breakers. So another place to really take advantage of the conduction losses, improvement in conduction losses, is a solid-state circuit breaker application, because electricity is continuously flowing through those circuit breakers. Solid-state circuit breakers have been something that the market has wanted to move to for a while, but the efficiency hasn't been good enough. And the reason for that is right now it's electromechanical breakers are being used. They're prone to wear. They're actually very slow acting. Because of that, they can create arcs, they can create fires, and it's a safety hazard. And you also have to maintain, because they are physical contact, and replace components of those breakers over time. So with the B-TRAN, it actually, because of its low conduction losses, enables this application. So we actually submitted a paper, a proposal, along with a company called Diversified Technologies. They're a private company with solid-state circuit breaker expertise and circuit breaker design expertise. We submitted it to the Navy. They decided to fund that under their Rapid Innovation Fund, which is designed to accelerate verticalization of high-impact, high-value technologies. And that was part of a 2-year program. It's been extended actually to a 3-year program. And we are actually in the process of delivering devices to DTI for the final circuit breaker design, which will then be demonstrated in a 12-kilovolt breaker at a site selected by the U.S. Navy. And their real focus is the ship electrification program, because they want to be able to control the energy flow and be able to shut off the energy flow quickly in the case of damage to part of the ship or part of a submarine. So this is something that they really want a family of different size solid-state circuit breakers. And the ultimate goal of this project, other than the demonstration, is Diversified Technology is required to present them a family of potential B-TRAN enabled solid-state circuit breakers for their ship electrification program. For us, I would say the military opportunity is a much longer term opportunity, but this is really critical in validating the technology for industrial and utility markets, where if you think of the aging infrastructure here in the United States, there's obviously a great opportunity for AC versions of solid-state circuit breakers as those infrastructure upgrades are implemented. In terms of commercial agreements and collaborations, we had some pretty significant news late last year. We entered into a development agreement with a top 10 global automaker for a custom B-TRAN module. So we're in phase 1 of that development program now. We'll be providing devices to them shortly under that program. And we're also in negotiations with them on phase 2 of that program, which will be working with a packaging company that they've also selected to actually make the custom B-TRAN module for use in their EV traction inverter. So they're looking for production-ready custom module in 2025. So it's a pretty large opportunity for us to get funded development dollars directly from a top 10 global automaker. We also have a test and evaluation program. We'll be delivering customer kits. These customer kits include a driver, test board, B-TRAN device, all in a safety enclosure. We'll be delivering those here in the second half of this year to a host of companies actually in our test and evaluation program, including a different top 10 global automaker. It's part of that program, top 10 global solar power conversion provider, Forbes Global 500 diverse power management market leader, leading commercial EV manufacturer, a tier 1 supplier that actually came to us as a result of the development agreement with the top 10 global automaker, and several other commercial entities that we have not in. As part of that program, they will evaluate the B-TRAN technology for use in their applications, and then they're actually required to provide us feedback. So we'll use that as a product planning process and make sure we incorporate their feedback into future B-TRAN products. Our 2023 milestones, first milestone we achieved here early this year was the launch of the SimPool power module. So this is a multi-die B-TRAN power module aimed specifically at the solid-state circuit breaker market because there's significant inbound interest for that application, particularly because of the Navy program. We're expecting, again, first commercial sales of that later here in 2023. We also expect in the second quarter, so pretty soon, to complete phase one of the multi-year development program with the top 10 global automaker. We're expecting to complete our first engineering run with the production fab in the second quarter. That's pretty significant for us. So to date, we've been working with 2 development fabs here in the United States, Teledyne and another fab that we have not announced the name of. But working with development fabs, it's generally small lots. The quality control is not the same as it is with a high volume fab. So it's been a little bit challenging getting the yield of devices we need, but we're already in the midst of that engineering run, and it is going extremely well. So we expect to have a lot more devices available for our customers here later this year. We have delivered some packaged B-TRAN devices to Diversified Technologies under that Navy program. We expect to have several more deliveries here in the second quarter of 2023. We also plan on introducing our second commercial product, really leveraging that SymCool power module by adding an integrated driver. That's really for industrial applications, renewables, energy storage, and other industrial uses. The introduction of that product we expect in the third quarter of this year. And then we'll deliver B-TRAN samples for the test and evaluation program that I had mentioned to those customers, including the second top 10 global automaker here in the second half of 2023. The technology is very well protected from a patent perspective. I think actually in the last week or so, this has changed 73 issued patents. We do have 24 pending patents as well. 31 of those are outside of the United States, places like China, Japan, Europe, India, and South Korea. And they're pretty broad in what they cover. So typically the device architecture itself, so again, it's a unique architecture, just like IGBT and MOSFET, unique architectures, but also controlling the device, for driving the device. And while we do have some double-sided device manufacturing techniques related patents, we generally treat the process flow, the steps to make a two-sided wafer and a two-sided B-TRAN device as a trade secret. So even if somebody had access to our patent, it took us several years to develop that process flow so that it could be taken from any silicon fab to another silicon fab, easily transferred. And that's some pretty important IP to us, because two-sided wafer processing is just typically not done in the semiconductor world. So it makes our technology particularly unique. And it also leads to our inherent bidirectional. In terms of recent news in our cap structure, you can see here many of our recent announcements, typically on the commercial front. We moved into the commercialization phase of the stage of the company. Shares outstanding, about 6 million shares outstanding on a fully diluted basis. About 7.8 million shares. Our cash balance at year end was $16.3 million. Should be, again, adequate to get us through 2024, which is what we're currently forecasting. So we do not have an immediate need to raise capital. And we have no debt on the balance sheet. It's a clean balance sheet, relatively simplistic. But with that, really appreciate your time and happy to answer any questions you need. Yes. Yeah, so they all have much different cycles in terms of timing. So obviously, probably the largest opportunity is the electric vehicle segment of the market. But that is a multi-year process. So the development agreement that we're working on phase one of right now, the intent is production ready, custom modules in 2025. So if we think about model year, we're looking at 2026 or 2027. So it's obviously a longer term opportunity. We'll have development revenue throughout that program. But earlier markets, so there's the solid-state circuit breaker market, which is a very large market. There's several companies focused in that area, companies like Eaton, ABB, and Siemens, and GE, and others. So there's a very large opportunity, much quicker for solid-state circuit breakers. Since we launched our first product, we expect some sales later this year, really ramping in 2024. And then with our second product that we're introducing later this year, it really opens up markets like renewable energy and energy storage. So you think things like solar paired with energy storage and other industrial markets where they want an integrated driver with the device. So we're looking at the revenue ramp starting in 2024 in the solid-state circuit breaker and industrial market. And then as you look longer term into 2026 and 2027, it's really largely driven by the biggest numbers by the EV space. All right. Well, if there's no other questions, I appreciate your time, and I'll be here the rest of the day today and tomorrow. Happy to answer any questions one-on-one. Thank you.